In this video, we're going to discuss significant figures. Significant figures deal with writing numbers to reflect precision. The precision of a measurement depends on the instrument used to make the measurement. The preservation of this precision during calculations can be accomplished by using significant figures. The greater the number of significant figures, the greater the certainty of the measurement. To determine the number of significant figures in a number, follow these rules. First, all non-zero digits are significant. Second, interior zeros, those are zeros that occur between two non-zero digits, are significant. If we look at the 408, that has 3 significant figures. If we look at the example 7.0301, that has 5 significant figures because the zeros in both of these numbers occur between non-zero digits. Rule 3 of significant figures is leading zeros are not significant. These zeros only serve to locate the decimal point. If we look at the number 0.0032, the leading zeros are not significant. Therefore, that answer only has 2 significant figures. If we look at the number 0.00006, the 4 leading zeros in that number are not significant. Therefore, that value only has 1 significant figure. The rules for trailing zeros fall under 3 categories. First, trailing zeros after a decimal point are always significant. In the number 45.000, the 3 zeros after the decimal point are significant. Therefore, there are 5 significant figures in that number. The example 3.5600 has 5 significant figures because of the same rule. Trailing zeros before a decimal point and after a non-zero number are always significant. If we look at the example 140.00, the 0 before the decimal point is significant. Therefore, there are 5 significant figures in that number. 2500.55 has 6 significant figures in that answer. Trailing zeros that occur before an implied decimal point are ambiguous and should be avoided by using scientific notation. The number 1200 does not have a decimal point at the end of the number, so it is said to be ambiguous, and we do not know how many significant figures there are. Looking at the example, if I want to indicate 2 significant figures, I would write the answer as 1.2 times 10 to the 3 in scientific notation. If I wanted to indicate 3 significant figures, I would write the answer as 1.20 times 10 to the 3. If I want to indicate 4 significant figures, I would write 1.200 times 10 to the 3. Decimal points are placed after one or more trailing zeros if the zeros are to be considered. Therefore, if I put a decimal point at the end of 1200, the 4 significant figures are now significant because of that decimal point at the end. Sometimes in chemistry, we will have exact numbers. These are numbers that have an unlimited number of significant figures. Usually these are counts, because we are counting discrete units of objects. Exact numbers are integral parts of an equation. These can be defined quantities. Some conversion factors are defined quantities while others are not, and you will refer to how I use them in class to understand how to count significant figures. In the next video, we will discuss using significant figures in calculations.